So we are back with another video, and since you all know that Reneet exam is there, so basically we will be looking at some short mock tests. So these are mini mock tests, a set of 4 to 5 questions, okay, which are highly useful for your upcoming exam. So the topic for today is primarily amines chapter, okay, amines chapter from organic chemistry. Fine. So the question says identify the correct statements, okay. First statement, primary amines do not give diazonium salts when treated with sodium nitrate in acidic condition. So this reaction, let's go one statement one by one, okay? So if this is a primary amine, you all know that in diazotization reaction, we have an amine, okay? And either it is sodium nitrate with dilute HCl, or it's simply written as HNO2 under 0 degree Celsius to 5 degree Celsius temperature range, you get a diazonium salt. Okay, so the first statement says, okay, that primary amines do not give primary amines do not give diazonium salts when treated with NaNO2 in acidic condition, but we know that primary amines do give this diazotization reaction, so it does give diazonium salts. So this is incorrect statement. You have been told to identify the correct statement. Next, aliphatic and aromatic primary amines on heating with chloroform, that is CHCl3, and ethanolic KOH, they form carbyl amines. So you know that for primary amines, okay, be it aliphatic or aromatic, for primary amines, I am taking the same example of aniline. For primary amines, when they are treated with CHCl3 along with basic medium, okay, this is called your carbyl amine reaction, and it is actually converted to isocyanate. Okay, this is your carbylamine reaction. So yes, aliphatic and aromatic, both types of primary amines, they give the carbylamine test. So B statement is correct. Since I have crossed A statement, I am going to remove option C. Okay, and B is correct. So B is in option A and B is in option D also. So out of A and D, one can be correct. So let's now look at C and D options. So secondary and tertiary amines also give carbylamine test. This can not be correct because we know that carbylamine test is only responded by primary amines as from statement B. So definitely your C is incorrect statement. So this cannot be the correct one. Okay. So definitely the correct answer is D. If we look at the other statements also, benzene sulfonyl chloride is known as Hinsberg reagent. So yes, Hinsberg reagent is basically pH SO2 Cl. This is your Hinsberg reagent. Okay, and basically in Hinsberg reagent, you know that primary amines, they give the adducts which are soluble in base. I will teach Hinsberg detection tests in great detail. Okay, but since this is a question solving session, so you just know this, that this is the Hinsberg reagent which reacts with amines. And last one is tertiary amines reacts with benzene sulfonyl chloride very easily. This is not correct statement. I just now told you primary reacts and gives base soluble alkali, reacts, the adduct is soluble in alkali. Secondary also reacts, but secondary does not have an active hydrogen left after reaction. So that's why it is not alkali soluble, and tertiary does not react. Okay, so this is the correct answer, option D. Let's go to next one quickly. Steam volatile compounds among the following are. Now, whenever in organic chemistry you learn about steam volatility, you learn about hydrogen bonding. So if I explain this to you properly, compounds which have intramolecular hydrogen bond, compounds with intramolecular hydrogen bonds. One of the prominent example in your textbook is orthonitrophenol. Okay, as you can see here, orthonitrophenol. So when there is intramolecular H bonding, the tendency to form hydrogen bonding with another molecule of same type, like for example, if you look at paranitrophenol, it can form hydrogen bonding with another NO2, okay, of another paranitrophenol molecule, and vice versa. This can also form, okay, with another molecule, and so on. So there is a cluster or agglomeration, or you can say aggregated type of structure when multiple molecules are coming together in the case of intermolecular hydrogen bonding. But when you are talking about intramolecular, since it is participating in H bonding within the same molecule, so that is why what happens is the tendency to cluster or form aggregates reduces. As a result, the boiling point, when you are boiling, this aggregates of hydrogen bonds, aggregates of multiple molecular units like this is difficult to break the overall bonds and vaporize or make it convert into steam, because here in intramolecular hydrogen bonding the tendency to form aggregates is less. It's forming bonding within its own molecule, so it's very easy to volatilize it. Okay, hence whenever there is question of your steam volatility, you look for intramolecular H bonding. Now coming back to your question, this one I have already explained to you. It's orthonitrophenol. Definitely this is steam volatile compound. And out of this I have told you para substituents means your intermolecular hydrogen bonding. Hence this and your this one is also ortho position, and you know nitrogen can also participate in hydrogen bonding. So here also if you look at the structure like this, NH2, okay, here also there is intramolecular hydrogen bonding. So A and B will be steam volatile. So your correct option will be option C. Okay. So for more questions, I'll be bringing more questions for you. Okay. So please stay tuned. And from now on till the NEET exam, I'll be bringing you regular questions, mini mock tests. Thank you.